Hello guys, we're back with our next lecture. In this lecture, let us go through the concept of a paging, guys. So paging is the best and the first approach for a non-contiguous memory allocation, guys. And I'm being 100% clear here. So most of the students and most of the faculty will always be getting scared when they are working with paging, guys, because it's an easy concept if you understand, and it is equally that much tough if you are not getting the exact idea or exactly how it is working. Okay, so that is the reason why I'll be making you a friend for this paging, guys. So please concentrate. The video might be around 10 to 20 minutes maybe at max, but you will get 100% clarity on this paging, guys. It will be your best friend from now on. Okay, so in that way I'll be teaching you, so please concentrate for some time. It will be really easy for you. Okay, yes. So first of all, why do we do paging, guys? So if you recall, in the last lecture we discussed about best fit approach and all those approaches, and I told you two different problems which are faced when we use a contiguous memory allocation. So what are those problems, guys? So the first problem is internal fragmentation and the second problem is external fragmentation. So among these two, we are going to solve this external fragmentation forever, guys. So you are never going to see external fragmentation when you talk about paging. That's it. There are no more words, nothing. So I'll be giving you the exact explanation why and everything also. So don't worry. Okay, yes. So the concept of this paging is it is a non-contiguous memory allocation. Okay, so I'll be giving you real-time examples while I'm discussing, guys, so please concentrate. Okay, yes. So assume that your secondary memory is 1 TB or 2 TB based on your PC's secondary memory, assume in that way. And similarly, your physical memory is some GBs based on your memory, based on your laptop or based on your system, which is 8 GB or 16 GB at max, right? Yes. So at that time, what will exactly happen is, this main secondary memory and main memory will be divided into equal slots, guys. So for easy understanding, in my book I have taken 1 KB slots. So the physical memory is divided into 1 KB slots. There might be some hundreds or thousands or lakhs or crores of slots in that way. Similarly, secondary memory is also going to have that 1 KB slots. The size should be same for both of them. But the count of these slots will be more in secondary memory, right? Because the secondary memory will be 1 TB. Okay, and when it comes to main memory, it is going to be 8 GB, right? Yes. So I'm taking some ideal cases. Okay, so if you want more clarity, instead of taking 1 KB, take it 1 GB, guys. So if it is 1 GB, here I am having 8 slots, whereas here I am having 1024 slots. So now you're understanding, right? So what is the exact difference? Yes, so here we are having lesser slots when compared to here, but each slot size is the same, right? So here also the slot size is 1 GB, here also the slot size is 1 GB. Okay, so now you are clear with this part, right? Yes, and each slot in this physical memory are called as a frames, guys. Please remember the terminology. So the slots in physical memory are called as a frames, and the slots in the main memory are called as a pages, guys. Okay, so now you're getting some idea, right? So these are called pages and these are called slots. So now your question will be, okay, so we divided it, and what is the main reason we divided it to the same size? So the main reason here is, so concentrate, guys. So assume that this is a page, right? So this is a bunch of pages, assume in that way, right? Yes. Okay, so assume them as a bunch of pages. So assume that I want to load all these people into this. So here how many are there? So assume these are 1024, or assume them as 200, guys. So I am having 200 pages which I want to load to main memory. But what is my main memory capacity, guys? I can store a maximum of 8 pages, that much only. So I cannot store anything more than that, right? Yes. So due to this, what we do is you will take one page which now your system wants. So assume that that is a movie, guys. So this is a movie. Okay, assume that this is a whole movie. So at that time, to run the whole movie, you need this all files. But at any moment of time, you are going to watch only few seconds, right? So if you are at 10 minutes time now, so after 10 minutes you will be at 20 minutes only, right? So you will not be at 50 minutes, or you will not be at 2 hour 10 minutes, right? So it will be going in a pattern. So that is the reason why you will load here page by page as per requirement, guys. So first you will load the first 10 minutes. So once the 10 minutes is completing, you will load the next page into this main memory. And once the previous page reading is done, so basically it will read in this way, right? So reading, you are watching the movie. So once the 10 minute is done, you will jump to the next page. So once you jump to that next frame, to the next frame, because we use frame here. So to the next frame, you will unload this previous page, right? Previous frame, right? So you will push that frame outside and that will be stored back into the main memory. Secondary memory, right? Yes. So this is the concept which we will use, guys. And the main reason why we are using the same slot size is because to avoid external fragmentation, guys. Right? Because if I am using different sizes, again there could be at the end I might end up with external fragmentation, right? That is the reason why we are using the same exact sizes, because if I take a particular page here, so that is fitting there successfully. If I take the same page, I can fit here also. So that is the major advantage here. So now you are getting the idea, right? Yes. So that is the reason why we can say that external fragmentation will be completely eliminated here. Okay. Yes. So now your question will be, okay, so we understood the concept now. So we are getting some idea, some basic idea with respect to it. So now what about this first part? So here it is a diagram of flowchart, something is there. So we are not getting it. Most of you are thinking, right? Yes. Okay. So if you recall, I told one important thing which is done by CPU in memory management. So what did I say? So the process of converting a logical address to physical address, right? Yes. So this concept will also be taken care by this structure, guys. So this is the exact structure and he is the king here. Okay. Yes. So what we do is CPU will generate a logical address, guys. Okay. So logical address will be indirectly of two parts. Okay. So the first part is a P and the second part is a D, guys. Okay, so here P is nothing but, so I'm not going through the full forms. So if you want, I can say the full forms also, but I don't want to confuse you with them, right? Yes. So let us assume a P here. First of all, let us assume P as the, okay, so P as the particular program number. So assume that this P as the program number P1. Okay, and similarly this D as the line number, guys. So what CPU says is go to program 1 and start reading from line number 10. So in this way it will say, okay, so let me give you the names only, why to confuse you again, right? Yes. So what CPU says is CPU, what it will say, guys, CPU will give always the data related to secondary memory, right? Yes. So CPU says that, so there is a page number 7. So because we call here the pages, right? So there is a page number 7. Its lines starts from 0 to 100. So please start reading from line number 10. So it will say in page number 7, read data from line number 10. But if you recall, can you directly communicate with secondary memory, guys? The answer is no. So that is the reason why we are going to convert this address into some other address. So what we will convert here is we are going to have a particular table called as a page table, guys. Okay, so this page table is going to contain the addresses. So basically, in simpler words, I'll be taking an example also, so don't worry. So in simpler words, if this is our page number, so this is page 4. So basically this slot, I'm going to take it and I'm going to place it somewhere in the main memory, right? Yes. So I have placed it and assume that this slot name is A. Okay, so now what I will do is I will make this entry into my table. Okay, so how I will make that entry is I will have that entry A here with the P7. Okay, so what will happen for what I am searching, guys? So for P7 I am searching. So what this page will do is page is connected here. So once it is connected here, so you will check that page 7 means indirectly it is a A. So what is a A? A is nothing but the frame number, right? Or frame name. So A is the frame name. So now this I will return. So now this F indicates a frame number, guys. This indicates a page number. So what is the final result which we got? So we got A comma 10. So what is the thing here? This indicates, so now your data which was previously at P7, so now it is at A10, right? Yes. So in A10 I can find the particular code. So now you got an idea, right? So what exactly is happening? Okay, so now we are getting the idea, right? So basically this particular copy I have copied here. So basically it will be here also, guys. So it's a multi copy, you can say. So for easy understanding, just give me a second. Okay, so this is a P7 and the code starts from 0 to 100 and the line number 10 is important. Okay, yes. So basically whenever you want, you will copy this particular thing and you will place in your main memory and it will be given a particular frame number, and this data you will update in your page table, guys. The reason why we update in the page table is because we cannot directly access the secondary memory. Got it? Yes. So now everything are connecting, right? So basically, mostly everyone got some basic idea at least, right? Yes. So if you are still having any kind of doubt, please rewatch the video again. Please listen carefully and understand the thing, guys. It's really easy, right? Yes. Okay, so here we are going to call them as pages, here we are going to call them as frames. Okay, and similarly here this is a page table, and the most important thing that you should understand is, so this is with respect to, assume the program is a program 10. Okay, so that is a program 10, assume in that way. So basically each and every program or each and every process is going to have its own page table, guys. Okay, and assume that there is a huge video which is of 20 GB. So at that time it will be occupying 20 different slots, right? Yes. So at any moment of time you can bring only 8 slots at max, right? And you are not going to fill the whole main memory with that, with those movie slots only, right? Yes. So that is the reason why if there are 2 slots, 2 pages here, so first you will bring these 2 pages. Okay, they will be here also, so you will assume in that way. Okay, yes, so they will be here also, so you will read these 2 slots, and once a particular slot is done, you will pop this slot out. Okay, and you will take the next slot and you will place it. So in this way the movie will continue, so there will be no interrupts. Got it? Yes. So the only thing, if you are having a doubt like how exactly is this really true, if you are having a doubt, please watch a movie, guys. So please play a video in your PC which is of a higher size, guys. So basically if your RAM is of 8 GB, so if you are having in your system, I'm not asking you or I'm forcing you. So if you are having any movie which is greater than 8 GB or greater than 4 GB also will work, I think so mostly. So just start watching the video and suddenly abruptly jump to the end, guys. So what it will happen is, in VLC media player you will see a loading, like it will load in yellow color. Right, so even for 700 movies, sometimes I will see it, guys, when my CPU is doing some other work. Okay, because there are no slots and this page is not yet loaded, so this page is pushed out and this page will be loaded at runtime. So that is indirectly paging concept is occurring in the backend, guys. So to be clear, paging is used by our systems in real time. Okay, so now you understood the whole logic, right? Yes. So now let us go through the example. So this example will be giving you much more clarity on the concept now. Okay, so assume that I am having a huge program or a huge movie which is of 6 slots. Okay, and I loaded these 6 slots. From these 6 slots, I loaded the first 4 slots into my main memory, and those slots are also loaded in some random order if you observe carefully, right? Yes. Okay, so once they are loaded, so this is our secondary memory, this is our main memory. So basically these slots information will also be filled in the page table, right? So at location A I can find P1, at location B I can find P2, at location C I can find P3, at location D I can find P4. Okay, so why did I write F? Okay, yes, so F here it indicates that it is nothing but the frames are stored here, that's it. Okay, yes. Okay, so now you got an idea, right? So this is filled. So now what will happen? So assume that we are searching for P2. So in P2 slot, page 2, we want 40-second line data. So this 40-second line, we are not going to mess with anything and we are just going to push it to the D. So here D is nothing but offset, guys. The word which we use is offset here. And this P is nothing but a page number. And F is nothing but the frame number. I think why, I don't know why didn't I specify them, but those are the things. Okay, yes. So whenever you are searching for P2, what we do is we go to the page table. You are going to map that P2. So where exactly that P2 is there in our frames. So at A location it is there. So sorry, at B location it is there. So you will search for B location, and in B location you are going to search for 40-second line. So that is the exact data which you want. So it's a piece of cake for you now, right? Yes. So the things which I have written here are exactly the same thing, guys. So P2 42, P2 is nothing but the page available and it's in the frame B. Hence it is a hit. So basically it is found, right? So if it is not found, so basically assume that I am searching for P6. So it is going to send an invalid. So basically it is not available currently. So that is what it will say, right? Yes. Okay, so the same example I have written here. So it's a miss. Okay, so we call it as a hit and miss. Okay, and one more important thing that you should remember is each and every process needs to store this page table also somewhere, right? Yes. So that page table location is stored in this PTBR, guys. It is nothing but a page table base register. So page table is also stored in main memory and its starting address is stored in the PTBR, page table base register. So here this page table, so assume this page table as P. So this P will also be stored here somewhere. So in that way it will work, guys. So now you are getting the idea, right? Yes, so that's what I want from you guys. Okay, yes, so the same concept I have clearly written here, guys. So the translation, how exactly the translation will occur. So we are having page number, we are having the PTBR, so hence we are going to search it and we are going to get it, right? Yes. Okay, and the same concept of page table also have written here. So now the major advantage here is so it is completely going to remove the external fragmentation. So few students will be like, we want a proof that the external fragmentation is gone. Okay, so let us take a simple example. Okay, so assume that there are total only two slots in this particular thing, guys. In this particular main memory or physical memory, there are only two slots. So what will happen if there are only two slots, guys? So what is the thing? So basically, if some other program wants to come inside, so assume this as a program and this wants to come inside. So basically someone will leave, right? Yes. Okay, so assume that this is only the new program. So if it wants to come, it can exactly fit, right? So why it will exactly fit? Because the size is same. So due to this size thing, how many times someone will go or someone will come or anyone will go or anyone will come. So there is no chance of any kind of wastage, right? Like there will be no slot wastage, and if there are 100 slots and alternate slots are filled, there is a chance that you can fill alternately or any random order, right? Because if you observe here I filled in different locations, I did not fill in a contiguous fashion. So that is also one more advantage with respect to paging, and that is also a solid reason why we are never going to have external fragmentation. But now few students will be like, okay, you are always saying about external fragmentation, then what about internal fragmentation? Is it possible? The answer is yes. So assume that your slot is a 1 KB here, but assume that a particular file came which size is only 1 byte. So at that time automatically the rest whole space is gone, right? Is wasted. So that is the reason why internal fragmentation still exists, and there is no particular method using which you can remove the internal and external fragmentation, guys. So that is the reason why this is one of the best approach, and we will be learning about segmentation, which is going to try to remove the internal fragmentation, but it is having some disadvantages. So we'll be learning about that pretty soon, so don't worry. So the disadvantage here is so the translation is slow, as a 2mm is there, 1 for page table and 2 for accessing the page. So this I'll be explaining you just in a second, guys, so please concentrate. So space wastage due to page table. So again we are going to store this page table also in our memory, right? So again this is also going to kill some space, right? Yes. Similarly, interfraction will be caused. Okay, so first let us discuss this thing. So basically concentrate here, guys. So this is our main memory, right? So indirectly this page table is also in our main memory. So indirectly when you are performing this translation, you are going to indirectly access this main memory and you are going to get this data, right? So one access to main memory is done to get the particular address, and the next memory access will be with this. So basically you will go for this F address. So where is that F? So if it is in B, you will go here. So this is one more memory access. So indirectly, just to get one slot of data, you are performing 2 memory location accesses. So which is not good, right? Yes. So this is a disadvantage, and this disadvantage will be solved, guys. Okay, so don't worry, there is an upgrade for this particular thing, and we will be solving that particular thing in the next lecture. Okay. Yes. So now I hope everyone at least are a bit friends with paging, right? So you got an exact idea, right? So how exactly it is working. So please watch the video again, or try to find a video in YouTube like animation for paging. So in that way. So if there are any videos like explained, so I have explained with the stick notes, right? So in that way, if someone has been explained with animation, it will be really clear for you guys, because this is an interesting concept, right? Yes. So now I hope everyone got a clear idea with respect to paging. So in the next lecture, let us discuss some problems, guys. So there are some problems which can be asked in our examination, because our examination, they will not ask us to draw the diagram, or they are not going to ask a 10-mark question to write this, that, right? Yes. So that is the reason why there are only standard problems which you can expect. So those problems we'll be discussing in the next lecture, guys. Okay. Yes. So I hope everyone got a clear idea with respect to this lecture. So in the next lecture, let us discuss the problems. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.